question 42. So we got parametric here equations given in terms of t. So it says then show that the tangent to c at the point P is given by this when we've got parameter little p. Of course, you need to find dy dx. To do that parametrically, you do dx dt to start with, which is 4. Dy dt then, which is 2t. Okay, when you differentiate, this becomes 4, this becomes 2t. Then to get dy dx, using the chain rule, of course the chain rule then is dy dt times dt dx, right? Because dy is on the top, it's dy dt, and dx is on the bottom, okay, from here. So yeah, you can see that, dy dx, dy is on the top, dy dt, and dx on the bottom, so dt dx. So what I should do here, right, and I sometimes forget to do this, but it's good to maybe write the flip of this up here, right? So that's dx dt, which we worked out, but we want dt dx. So you flip this, the reciprocal of this then will be 1/4, okay? And it's good to write it there, actually. So dy dt is 2t, dt dx is 1/4. This becomes then t upon 2, right, when you simplify it. Now at this point P, right, at this point P, right, the parameter, right, and parameter now is t, right, but it says is equal to, if you look at the question, it says is equal to little b, yeah, so at the point P, it's got parameter little p. In other words, t is equal to little p, right? So what we'll do then is, we're going to substitute this then into here, okay, dy dx. So we say, therefore, dy dx equals to little p upon 2, okay, that's what we've got there. Okay, that's what my dy dx is, because t is little p, so we've got p upon 2. So also as well, of course, we need to understand that, look, you know, also at p, because t is little p, we've got the gradient, you know, and this is the gradient of the tangent, isn't it? Okay, which is important, because some questions they'll want the normal, right? So you'd have to do the m1, m2 thing, equals -1, but they do say the tangent in this case. Of course, you need to write out an x, with the x value as well. So x then, going back to the equations they give us, x will be this, y will be p squared minus 5. So then to get the equation, right, it'll be y minus y1 equals mx minus x1. So y minus y1, which is p squared minus 5, gradient then is p over 2, and then x1 then is 4p minus 1. So then this becomes y minus p squared plus 5 equals, let's simplify this a bit first. Okay, now what I would do now is maybe take that 2 up here. Okay, and then we need to then basically get what they've got in this question, right? So get it in that form. So we've got the px, and then if I take this over this side, that'll become a plus, so you end up having minus. No, we don't need it like that, don't we? We need to take the 2y over, not the question, and then take this over that side. So that becomes a plus 2p squared, that works, and then you've got to take the p over as minus p, and then plus 10, so you get exactly what they want, okay? So then it says in the question, okay, then it says in the question, what's it say? The tangent to C at the point P passes through the point 2 minus 12, okay? Given that the point P is in the third quadrant, find the equation of the tangent. Okay, so given it says this, right, okay, we could say, look, the tangent passes through this. In other words then, this point P, right, tangent that passes through the point P, sorry, passes through this point. So it's not, this isn't point P, right, it's just you've got this curve, right, some sort of curve, and then you've got your tangent then at P, and it's saying then it passes through this other point, right? This is your tangent going down, it passes through this point here. Oh, I got the coordinates all messed up here, but you get the idea, don't you? You know, it's in the wrong place, doesn't matter. But the tangent at P passes through another point here, right? 2 minus 12, okay? So what we could say is then, look, this point, 2 minus 12, must satisfy tangent equation. Okay? In other words, this must work in here, right? Because it passes through that point. So it fits in here. So we can substitute it in, right? So we'll have p times 2, okay, for x. Take away 2 then, and y then is minus 12. Equals then 2p squared minus p plus 10. So this then becomes 2p plus 24 equals 2p squared minus p plus 10. Get everything to one side. 2p squared minus 3p, okay, minus 14 equals 0, right? So you've got to factorize this, right? So, you know, whichever method you use, right? Whichever method you're taught. In this case now, you go in this method, you times the front there by the 14, which is 28, so minus 28, and you've got to add up then to give minus 3, so it's two numbers. 7 and 4 would work. And to get minus 3, this would have to be minus 7, right? So in your brackets then, 2p minus 7, 2p plus 4 equals 0. Of course, you divide the whole thing by 2, because you times by 2 up here. Take a 2 out there. 2's will cancel, so that means then 2p minus 7 equals 0, or p plus 2 equals 0. So p then would equal 7 over 2, or p would equal minus 2. Okay, now what I'm going to do next now is I'm going to substitute it in, okay, to work out what my point is, right? Now, it does say it's in the third quadrant, right? In the third quadrant, this is your first, right? This is always your first quadrant because everything's positive, and this is the one we learn first, isn't it? In primary school, you learn all the positive values. That's the first. Then you go anti-clockwise. That's the second. The third is here. Okay, the third is here. Now, we need to sub these in, and really here we need to have x negative, don't we, and y negative, right? So if I sub it in to x equals, remember now x would equals to 4p minus 1, didn't it? So x would equal then 4 times 7 over 2 minus 1. So I work that out, that comes to be 13, okay? So that's no good, because that means you'd be in the first quadrant. So ignore this, right? Okay, p, you know, ignore this value, right? So we check p equals minus 2. So x will equal 4 times minus 2 minus 1. X will equal minus 9, that's good. And y then, looking at the y equation that we had, minus 2 all squared minus 5. So that would equal minus 1. So that works, right? So my coordinate that it goes through is minus 1, minus 9, sorry, minus 1. Okay? And the gradient, of course, the gradient at that point then is what we've got, isn't it? With regards to the curve. Where am I getting lost now? So what we do then is it says find the equation of the tangent, right? Now, what you do then is you go back to what you established in part A, right? And if you think about what we established in part A, we had px minus 2y equals 2p squared minus p plus 10. That's the equation of the tangent. But then to get the equation of the tangent then, what we do then is we sub these in, right? To get it even more specific, we sub these in. So we got p times minus 9 minus 2 then times minus 1 goes to 2p squared minus p plus 10. Okay, so this will be then minus 9p plus 2 equals 2p squared minus p plus 10. So you get 2p squared, take that over, so it would be plus 8p, and take that over, plus 8 equals 0. And there's my equation of the tangent. Okay, it's even more specific than what was given before.